Math 287, Cuesta College. I'm Joe Vasta. This is section 10.2, the inverse Laplace transform, sometimes just called the inverse transform. So, we have the Laplace transform of these four functions, and here are their Laplace transforms on the right-hand side. The Laplace transform is a linear transformation, so these are all vectors, and they take a linear transformation into another vector space over here, and these guys are all vectors as well. Well, it just so happens that with the Laplace transform, you have an inverse transform, L inverse, which takes us back to the land of t. So when we do our homework in this, they'll ask us to find the inverse Laplace transform, and they'll give us things that are in terms of s's, and we're going to bring them back into terms of t's. So let's go ahead and do this, and we're not going to use the definition of the Laplace transform to get back. We're going to use those shortcuts. I'm going to do things a little differently than the book. Let's go ahead and look at some problems here. Find the inverse Laplace transform. See, look, it says f of s, and our answer is going to be little f of t. So we look on our list here. Okay, so here's our list, and we're like, do we notice anything that looks like a number over s minus a number? And it's this one right here. Well, the number is 1 there, so I have this inverse transform, 1 over s minus a, takes me back to e to the at. So what I'm going to do, and a lot of you don't need to do this after you do a few of these, is I'm going to go ahead and put the 8 out front. And so now this fits the mold. We are ready to send this creature back to the land of t. And so here it goes. F of t is 8. And going back, so these, you should try to memorize these things. 1 over s minus a gets transformed to e to the at, so this one's going to get transformed to e to the 5t. And so we have the 8 in front of there, and there's our answer. Okay, so that is how you do the inverse Laplace transform. Let's go ahead and try another one right here. This is f of s equals 10 over s to the 5th. Okay, so we have, I'm going to go ahead and write this like this. F of s equals 10, and then we have 1 over s to the 5th. Okay, so at the bottom, I'm going to go ahead and write out the rule so I don't have to keep moving the paper around. T to the n gets transformed to n factorial all over s to the n plus 1 power. Okay, so your book's going to give you a whole set of rules for the inverse transforms. I like to use the 4 rules that I have. So what I have down here is I have s to the n plus 1. I have this s to the 5th. So on the top, and I'll use a different color, I'll use purple here, I'm going to put not a 5 factorial, but I'm going to put a 4 factorial. Now we know in math you can't just go around putting 4 factorials here or there, wherever you want. Just like you can't go around the golf course going 4 when you're not even hitting a ball. So what? Okay, so that was my attempt at humor, and it's not really working because, you know, putting things on this piece of paper, everything has changed. And I don't want these things to be too funny or too popular, because then the administration might come along and say, we don't need you anymore, we've got your videos. So if you're finding that this is not as fun as coming to class, that's on purpose. Okay, so let's balance the books. We have 4 factorial, which we need it for this. And then on the bottom, to balance the books, I'm going to put 4 factorial in front of that 10. And I'm going to put parentheses around here, and this might remind you of that old TV show Star Trek, where now this guy's ready to energize. So Scotty's there, and we are going to say energize, and you hear that sound, and so this guy's going to get transformed, so inverse transformed, to what? It's going to get inverse transformed to the n factorial, so it's going to be t to the 4th. And so that's what's going to happen. So out front here we have 10 over 24, that's 4 factorial. This is times t to the 4th. Okay, so we've just gone this way on this Laplace transform. We've done the inverse transform. Let's go ahead and clean up our answer so it looks pretty here. F of t is 5/12. We'll reduce that fraction. T to the 4th. So that's what you're going to be doing in your homework. You're going to be using these shortcuts, but you're going to be using them backwards. Also, you could, cover up all the work and find the Laplace transform of this, and you'll end up getting this guy right here. And same with this one. If you find the Laplace transform covering up all that work, you'll end up, you'll do this shortcut. And you'll go, oh, look, 4 factorial on the top over s to the 5th, and then 5/12. So you'll end up getting 10 over s to the 5th. Let's go ahead and do another problem. By the way, this is pretty much all you do in 10.2, the inverse transform. And so this problem right here, let me just look at my notes here. Yeah, this is the last problem I'm going to do from 10.2. So the lecture from 10.2 is pretty short, no derivations, just can we do the shortcuts backwards. Now this one's going to be a little bit hairier because, wow, look at that. How am I going to take the Laplace transform? Let's look at my shortcuts. Do I have this? No. Okay, I have like more complication on the bottom there than I do here. Do I have an s minus a on the bottom? No. S squared plus b squared. So at this point, we just want to give up on this, and that's not what we're going to do. What we're going to do is we're going to do this. So maybe you know what that stands for. Partial fraction decomposition. So let's go ahead and do partial fraction decomposition, and that's going to be probably the worst part for some of you guys in doing chapter 10, because that is a skill that needs to be there when you do your homework, because this is going to happen a lot. Partial fraction decomposition. Well, how do I do that, and why did I just write it again? Okay, I'm going to factor the bottom if I can, and I can factor the bottom. I can factor an s out of the bottom. So I have an s times s squared plus 9 on the bottom, and then on the top, even though it may or may not be able to be factored over the rationals, we don't. We just leave it like this. Okay, so now partial fraction decomposition says we have a linear factor, so you go a divided by the linear factor. This right here is a quadratic factor, so with our quadratic factor we're going to go bs plus c over the quadratic factor. Now there is a review of partial fraction decomposition in the appendix of your book. It probably does a good job. And so if if it's been a while, you might want to look at some of those problems in the appendix of your book. But I'm going to walk through this one here. So what am I going to do next? I'm going to go ahead and multiply this equation by the LCD of s squared plus 9. So on the left-hand side, I'm just going to get the numerator there. So I have 6s squared minus 5s plus 36 equals this term. When you multiply it by that red thing there, the s's are going to cancel, and you're going to get a times s squared plus 9. And then this last term, the s squared plus 9s are going to cancel, and you're going to get plus bs plus c times s. And so that's what we have there. And so there are a few approaches to doing partial fraction decomposition. One thing you can do, and I always try to do this when I can, is on this equation here, if you can let s equal a value that will kill off some of these a's, b's, and c's. And if you let s equal 0, not that this is going to get the problem done, but it might get us some results instantly. You'll get on the left-hand side, 36, and on the right-hand side, you'll get a times 9, and then this guy right here is 0. So this gives us 9a equals 36, or a equals 4. There it is. Like, we got instant results just by zeroing out the s. But we can't do that anymore. So some of you are like, you couldn't do that anymore. But that's all right. We did it so we know what a is. And so a is, I'll go ahead and replace it, 4. Now, did we have to do that? No. I'm going to go ahead and multiply the 4 through and the s through. We're going to distribute, and I'll write out this equation now. This is 6s squared minus 5s plus 36 equals 4s squared plus 36, and then we have plus bs squared plus cs. Okay, let's go ahead and look at our s squareds, and I'll underline them in red. And so what I'm going to do with that is I'm going to say that the coefficients are going to be equal. So we're going to have 6 equals 4 plus b, because that's what the red gives us. I'll circle this in red here. And the blue, I'm going to underline all the just plain s's in blue. This is going to give me -5 equals c. So we pretty much know how to finish this off, but we'll continue. And then I'm going to underline all the constants in green. 36, 36. Good thing that 36 equals 36. If it said 36 equals 37, then something's wrong. We'll circle that. So from the red equation, we get b. Let's see if I have more scratch paper here. Okay, so I do have enough here. So I'm going to get b equals 2, and c is -5. So I know that a is 4, b is 2, c is -5. I can rewrite this guy right here. So I have a over s, that's 4 over s, plus 2s, see, bs plus c, or -5. This is all over s squared plus 9. That is the functions. If we do any calculus or any differential equations or anything here, we didn't even do a Laplace transform. All we did was some algebra that a lot of people learn in a pre-calculus class. Okay, let's continue. We're trying to find the inverse transform of this. I think we can find the inverse transform of the first one because it's, we have the n factor. We'll do that, but the second one still looks crazy. It has an s squared plus 9. It reminds us of this s squared plus b squared, s squared plus b squared, but there's only like one thing on the top of those. So what I'm going to do is I'm going to split that fraction. Okay, so here goes. I have 4 over s plus 2s over s squared plus 9. Then we have minus 5 over s squared plus 9. Now we have to write this thing and get the people on the platform, get the functions on the platform, and then energize and take the inverse transform. So I'm going to go like this and go 4 times 1 over s. Okay, so why is that significant? This s, so we have this rule here that says t to the n gets transformed to n factorial over s to the n plus 1. So we have that. That's a rule there. We have n is 0 in this case. And so you do have a 0 factorial, And so you know that this 1 over s, we're ready to inverse transform that, and that's actually just going to be t to the 0, which is 1. As you do more of these, you're going to just kind of memorize these a little better than always going back to the formula for something like this. Now the other formula for the cosine and the sine, so let's go ahead and put these guys here. So the cosine of bt, it gets transformed to s over s squared plus b squared. And then the sine of bt gets transformed to b over s squared plus b squared. So we see an s up here, so we know this one's going to turn into the cosine. We're going to bring the 2 out of there, so it looks like this. So it looks like s all over s squared plus 9. And then this last one, you see an s squared, okay, down here, s squared plus b squared. Well, b squared, what is b? B is just going to be 3. So what you need on the top is not a 5. What you need on the top of that is a 3. So put 1 there. Okay, so we're trying to match this formula. But you have to balance the books by putting 1 out there. And then you have an s squared plus 9 on the bottom, okay, because that's what we have there. So now these guys in the parentheses are ready to energize or whatever. We're going to take the inverse transform. So the inverse transform of 1 over s using this formula is t to the 0 or just 1. So it's going to be 4 times 1, so 4. The inverse transform of s over s squared plus 9, or that's s squared plus 3 squared, is going to be the cosine of 3t. And we have minus 5/3, the inverse transform of 3 over s squared plus 9. Well, it fits this mold, so it's going to be the sine of 3t. And so that is our answer. And this completes section 10.2, the inverse transform. Work on your homework and have a good day.